China is one of the largest economies in the world, and with its sheer volume of talented engineers and equipment, China now leads the infrastructure race by building bridges and roads that leave even the most experienced engineers in awe today. We'll be looking at some of these projects and how they got it done so well. Before we start this video, make sure to like this video and subscribe so you can keep up to date with all our videos. In the 60s and 70s, it was a race between America and Europe, building a ton of bridges and roads on their land. In the 90s, Japan joined in and was ahead in the infrastructure race, but that didn't last long at all since China soon joined the fray and started building mammoth bridges and endless long highways at a rate that the other countries could not keep up. If that doesn't give you a clue as to how fast they work, here's another one. China is building roads so fast that the multiple companies who have been given contracts to build side stations, such as fuel stations and convenience stores, have not been able to keep up with the fast pace of how China is building their roads and bridges. What is their secret and why they're so good at building bridges and roads? It's a mix of manpower and engineering prowess that led them to build a series of amazing machines, and let's take a look at a few of them and see just what makes them special. No matter how big and complex machines get, nothing will ever beat the sheer will of humans. After all, it's humans and their ingenuity that help build amazing machines. Ever since China opened its economy to its world, it has been in a race to catch up with the world on infrastructure, and China has ever since been on a so-called infrastructure crazy, and the booming economy not only helped more than 800 million people from below poverty, it also helped the people of China to get a better education, better training, and new scientific breakthroughs to reach their goals. The new generation of Chinese engineers have what it takes to the country far beyond what we can imagine, and that's all thanks to their education and a booming economy that lets them practice to make their engineering dreams come true. Let's look at some of these examples of breakthroughs that is helping build modern China. The SLJ 900. The SLJ 900 is an all-Chinese big chunk of metal built by Beijing Baojoint Machinery Company, and which was designed and engineered by Shijiazhuang Railway Design Institute, is a 7-meter wide, 90-meter long colossal giant weighing roughly 580 tons. The way how the machine works is quite simple. Well, at least on paper it is. The huge machine picks up a ready-made section of the bridge and then transports it to complete the next section of the bridge. This is, however, limited to only bridges that are called girder-type bridges. These bridges are sections of concrete placed on top of pillars. Once the pillar are placed, the SLJ 900 drops its pneumatic anchors and holds onto the first pillar, then it can hover above the bridge, carrying a girder section to the next pillar, and then place it down to finish the next section, and this follows until the whole bridge is completed. The pillars need to be placed beforehand, and the girders can be brought in one by one by specially designed trucks that can handle the massive weight and length of these girders. The best thing about this machine is that it has 64 wheels and can move both forward and backward and sideways as well, which makes this huge giant very maneuverable. This machine can also travel up to speeds of 5 kilometers per hour, which may seem very slow to all of us, but when you compare it to the traditional method of building bridges, which is set up a couple of cranes which are stationary and can only move their booms, the SLJ 900 is truly light years faster than the competition. This machine is expected to build over 750 bridges in its entire lifetime. What makes the SLJ 900 truly one of a kind is that it helps keep the cost of building bridges low, and one of the factors is that it can move on its own and doesn't need a whole team of expert moves and operators to move it one from place to another. Another way it helps saves money is by cutting down on manpower, with a projected decrease of over 20% of the workforce needed compared to the current building methods. This huge monster not only builds faster, but also cuts down the costs in terms of labor. Kunlun. With building bridges, comes with it heavy loads and heavy girders, and it seems to be China's go-to method of building bridges. So it would only some time before they built something that was humongous and could build bridges efficiently and with great speed. This is where Kunlun comes in. The name Kunlun comes from a mountain range famous for its massive peaks and beautiful views. This machine was engineered and made by the China Railway 5th Survey and Design Institute, and it's the world's first 1,000-ton transport machine that can lift huge sections of road bridges or railway bridges weighing up to 1,000 tons. This machine is a testament to the rapidly progressing Chinese economy and its desire and dream of being an infrastructure leader. The Kunlun is the first great girder erector that can carry and move a 40-meter section of girder, but that's not all. This machine can also be adjusted to transport a 24-meter or a 32-meter or the biggest of them all, a 40-meter girder section for bridges. This means that instead of carrying or transporting 3 different box girder erectors, the Kunlun can do the job of 3 different machines, and that too very efficiently. This machine is certainly one of its kind and is mainly used to complete girder sections between waterways and valleys to make building the bridges easier. But one does get thinking, why build bigger and bigger girders in which they need to make bigger and bigger machines to accommodate this? The answer is quite simple. More longer girder means fewer parts involved in making a bridge, and this is especially helpful when you're building high-speed railways. Fewer parts mean fewer gaps between bridges and less movement between the girders, which means when the high-speed trains go through these bridges, it means more comfortable and less shaky rides.